Inductors and inductance. An inductor can be used to produce a designed magnetic field. We should consider a long solenoid, more specifically a short length near the middle of the long solenoid, as our basic type of inductor. If we establish a current I in the windings or turns of an inductor, a solenoid, the current produces a magnetic flux phi throughout the central region of the inductor. The inductance of the inductor is then L equals N phi over I, the definition, in which N is the numbers of the turns. L equals N phi over I. The windings of the inductor are said to be linked by the shared flux, and the product N phi is called the magnetic flux linkage. The inductance L is thus a measure of the flux linkage produced by the inductor per unit current. The metric system unit of inductance. This is Henry. This is a flux, Tesla meter square, and this is ampere. As 1 Henry equal to 1 Tesla meter square over Henry. Throughout the rest of this chapter, we assume that all inductors, no matter what their geometric arrangement, have no magnetic materials such as iron in their vicinity. Such materials will distort the magnetic field of an inductor. Inductance of solenoid. N, the number of turns per unit length. This per unit length is per meter. L, the length of the solenoid. B, the magnetic field within the solenoid. We have learned in the last chapter, B equal to mu 0 N I. N is the turns per unit length. A, the cross-sectional area. L equals N phi over I. And N phi is N is the total number equal to NL. This is the turn per unit length. This is the length. And phi is BA. So we put this one here, we got L equal to NLBA over I. And B, we know that equal to mu 0 and I. Put this one B inside, I cancel out. So the L equals mu 0 N squared LA. And we divide the L over the inductance per unit length equal to mu 0 N squared over A. There's nothing to do with current. Thus, the inductance per unit length for a long solenoid near its center is L over mu 0 N squared A. It depends only on geometric factors, nothing to do with current. If the solenoid is very much longer than its radius, then equation gives its inductance to a good approximation. This approximation neglects the spreading of the magnetic field lines near the end of the solenoid. Mu 0 can be expressed in the unit Henry per meter. Okay, this mu 0 can be Henry. Okay, so mu 0 equal to 4 pi times 10 to the minus 7 Tesla meter per ampere, equal to 4 pi times 10 to the minus 7 Henry over meter.